Hello students, welcome back to Akshar IIT Foundation classes. I am your chemistry faculty S. Mohan. Grade 6 IIT Foundation Chemistry. Previously we are completed two chapters. One is Language of Chemistry and second one Changes Around Us. Now today I am going to start a new chapter, that is atomic structure. Atomic structure. It's the third chapter and very important chapter. So this atomic structure is a very important chapter for IIT Mains, J Mains, and even advanced. Okay. So as you see here, atomic structure, actually it is in the regular classes, it will be there from the 9th class onwards, 9th, 10th and into first year. So the 11th standard, this classes are there, atomic structure. But now we are going to discuss about the atomic structure today. So students, here, atomic structure. What is meant by the atomic structure? So it's nothing but a structure of an atom. How the atom is present, okay, and what it constitutes, how it is made up of, what is its composition, and what are they present in the atom. Everything about the structure of an atom we are going to discuss in this one. So before going to that, first let us see what is an atom. So students, already from the two chapters we have discussed about the atoms, elements, molecules and everything, and you know about the atom very well, but still let's see here. So here Dalton theory was disproved and so many changes have come. Most of the points was proved as wrong with the Dalton's atomic theory, and here the atoms are indivisible. That is the main point of the J. Thomson, right? Sorry, John Dalton. But it was proved as wrong by J. Thomson. J. Thomson was a scientist who conducted one experiment called as a discharge tube experiment, and from that term he discovered the electrons. And after that, and electrons are negatively charged particles. I think you know this one. Later, positively charged particles were discovered, which are named as a protons. And later, after long back, means okay, in 1932, I think. So James Chadwick discovered the neutrons. So now these three particles, so many other particles also there in an atom, but the most important particles that play key role, okay, in the properties of an atom are three particles: electrons, protons and neutrons. They are called fundamental particles. What they are called? Fundamental particles. So these fundamental particles are three are there, okay, electrons, protons and neutrons, right? Now let us see what are these electrons, protons and neutrons. So first let us see electrons. Electrons are the negatively charged particle. What they are? Negatively charged particle, means they have the negative charge, right? And protons are the positively charged particles. Protons are what? Positively charged particles. And neutrons are neutral. Neutral means what? Zero. The charge is zero. They do not have any charge, right? So these are about the electrons or negatively charged particle. Next, the mass of the electrons, if you see, the mass of the electrons is negligible. Negligible means what? Compared to the mass of the atom, it's very less. So that's what we don't consider the mass of the atom. But still, as I told you, the science and technology developed a lot. So here the scientists also calculated the mass of the electron, and the mass of the electron is 9.11 into 10 to the power of minus 28 students here, minus 28 grams, or we can write 0.000584 AMU. AMU stands for what? Atomic mass unit. AMU stands for what? Atomic mass unit. Okay. So that is the mass of the what is the mass of that? Is the mass of the electron. Now what is the proton's mass? Proton's mass is 1.602. 1.672 into 10 to the power of minus 24 grams or 1.007277 AMU. Okay, AMU. And what is the mass of neutron is almost same of this one. So that is 1.675 into 10 to the power of minus 24 grams. Okay. Or you can write 1.008665 AMU. Okay. So these are the masses of electrons, protons and neutrons. Okay. So these are the masses of the electrons. So in the grams, the electron mass is 9.11 into 10 to the power of minus 28 grams. Here proton is 1.672 into 10 to the power of minus 24 and neutron is 1.675 into 10 to the power of minus 24 grams, right? Then, okay, a relatively charge is also given, the relative charge of electron. This negatively charge which discussed, no? So that generally charge is measured in the terms of coulombs. Okay, coulombs. Coulombs is a SI unit of the charge and the charge is minus 1.602 into 10 to the power of minus 19 coulombs. This is a charge. Okay, but negative. So it's here negative charge. Okay, and protons also equal charge, but they are in positive. So what you can write here? Plus 1.602 into 10 to the power of minus 19. Okay, coulombs. This also. And this is 0, so we need not to write the charge. Okay, I am writing 0. And students, here charge can also be expressed in ESU. ESU stands for electrostatic units, and in terms of electrostatic units, the charge is minus 4.8 into 10 to the power of minus 10 ESU. And whereas the positive charge, okay, proton same charge but only sign. Okay, so this becomes plus 4.8 into 10 to the power of minus 19 coulombs, and it is 0 charge. So in this way, we can see the charges and masses of an subatomic particles. Okay. Now in this, if you see the atomic structure, in the atomic structure means all these are present in the atom. Then when you divide the atom, so from that atoms where we can find these electrons, protons, neutrons. But where these particles are present, okay. So here if you see, we discussed in detail about the atomic structure, but as of now you see here, generally these protons and neutrons are present in the nucleus of an atom. Where they are present? Nucleus of an atom. What is a nucleus? Nucleus means what? A central small region which is present in the atom. If you think that most of the atoms are spherical in shape, how they are spherical? Means like round. Okay. Inside there is a small region will be there, very small region. That small region is called nucleus. Okay. In that nucleus, the protons and neutrons will be present in the nucleus, and electrons will be revolving around the nucleus in the specified circular paths. Okay. So like these shells are there, like K, L, M, N shells are there. So in this shells, the electrons will be revolving around the nucleus. Okay. So this is about the atomic structure. 1, 2, 3, 4, 5, 6, 7, 8, 8 only. Okay. So electrons revolve around the nucleus in the specified circular path, and these are called as the orbits or shells. What they are called? Orbits or shells. Okay. So these electrons will be revolving, and here this is what the nucleus. What it is? Nucleus. The nucleus, what are there? Protons and neutrons are present in the nucleus, and electrons are revolving around the nucleus in the various orbits, right? And students, here, as protons or neutrons are present in nucleus, this collectively means together. Protons and neutrons are collectively called as nucleons. What they are called? Nucleons. Nucleons. Why they are called nucleons? Because they are present in the nucleus. Okay, so that's all about this atomic structure. So once you've seen your material, page number 135, proton. It's a lightest positively charged particle of hydrogen. Positively charged particle. It is present in the center of atom, which was discovered by the Goldstein. This also we write. Okay. So here, electrons were discovered by the J.J. Thomson. J.J. Thomson, and here it is discovered by the Goldstein. Okay. Here James Chadwick discovered the neutrons. Okay, chalo, right. So these are the subatomic particles who were discovered. So see here now, page number 135. Proton is the lightest positively charged particle of hydrogen present in the center of atom, which was discovered by the Goldstein. Electron is a negatively charged particle. It was discovered by the J.J. Thomson, but the name was given by the J.J. Stoney. Okay. Neutron was discovered by no charge, and it is discovered by the Chadwick. And simple electronic structure atom consists of three particles: protons, neutrons, and electrons. In that, protons and neutrons are present in the nucleus, and electrons will be revolving around the nucleus. Okay, in the various orbits or shells like this, right? And your fundamental particles properties are given. Comparison. So let's go through that comparison. So with this is done. This chapter is this exercise. This first synopsis is done. Okay. Now concept based question is there. You can see here the term atom was given by John Dalton. Okay. These are very simple. You can do it. Who proposed that matter is made up of extremely small particles called atoms. Here also you can give John Dalton only. Next, a neutral atom always possesses which particles? Neutrons, protons, and electrons. Neutrons, protons, and electrons. The answer is 4. Neutron possess no charge, 0. Atom of an element consists equal number of protons and neutrons. Both will have the same number of protons and neutrons. Which of the following is not a fundamental particle? Electron, proton, neutron. But here one more is there, positron. Positron is not a fundamental particle. What are the nucleons? Seventh question, nucleons. So see here, nucleons means what? The present protons and neutrons, because they are present in the nucleus. An elemental particle is subatomic particle. You can write, that's a 4. The name of electron was coined by J.J. Stoney. Fourth option. Which of the following subatomic particle carries negative charge? Negative charge, that is electron. So option is 2. The mass of electron 0.000548. So the option is 1. Who discovered the nucleus? Nucleus was discovered by the Rutherford by his famous experiment called alpha ray scattering experiment or gold foil experiment that we discuss in the detail in the next classes. Right. So students, I am continuing with the second topic also. This very simple. Okay, atomic number, mass number, calculation of number of neutrons. Small topic. So synopsis 2 we are going to do now only. So students, now we are going to do the synopsis 2 of atomic structure. In the synopsis 2, arrangement of the particles, okay, so here we see the symbolic representation of atom first. So see students, here every atom consists of electrons, protons and neutrons. Of course, hydrogen is the only element which do not contain the neutrons, but still remaining all elements consist of electrons, protons and neutrons. Okay. So here the number of protons present in an atom, is called its atomic number. Already we discussed in the language of chemistry. Okay, to write the electronic configuration and everything. So see students, here atomic number. So first we see atomic number. Atomic number means the number of protons in an atom or present in the nucleus of an atom. Anything you can write, no problem, but that represents the protons. Okay, the number of protons in an atom is called the atomic number. And atomic number is denoted by Z. which letter? Z. Okay. And in a neutral atom means what? Generally, okay, atoms in the regular state. Neutral atom means what? Actually no charge. In a neutral atom, the number of protons is equal to number of electrons. Okay. So, number of protons is also equal to number of electrons. So, Z is also equal to number of electrons. Number of electrons. So, the meaning is what? In a neutral atom, okay, the number of electrons and protons are same. This you have to remember. The important point is this here. Okay. So, atomic number means what? The number of protons in an atom is called atomic number. It is denoted by Z. In any neutral atom, the number of protons is also equal to number of electrons. So, E is equal to P. Right. Now, then come to the mass number. Mass number. Okay. So, mass number means what? The sum of the protons and neutrons. What the mass number means? Sum of protons and neutrons. So, here what is the sum? Sum is what? Addition. Addition. So, addition of protons and neutrons. So, just simply write P plus N. So, what is this? Mass number. Mass number is denoted by A is equal to P plus N. So, P means number of protons and N means what? Number of neutrons. Now, number of protons here, number of protons is represented with what? Z. So, we can write the equation as same. A is equal to P. P means what? Number of protons. But protons is represented with Z. So, just you replace P with Z. So, this becomes Z plus N. So, this is the formula for mass number. Right. Now, if you want to find the number of neutrons if you want to find, then very simple. Okay. So, just P bring this side. So, this becomes plus P. When it comes here, it becomes minus P. So, A minus P is equal to N. So, therefore, N is equal to A minus P. P means what is Z here. So, the meaning is what? Number of neutrons you can calculate by subtracting the atomic number from the mass number. Clear? Very simple. Now, one important point I will explain you. That is a representation of an atom. How atom of an element can be represented in short. Okay. So, see students, if I want to represent like hydrogen, I want to represent the hydrogen. Okay. Whose atomic number is 1, mass number is also 1. Atomic number 1, mass number 1. So, how can I represent this hydrogen with atom? So, here I am writing hydrogen. So, hydrogen, its atomic number 1. So, I will write 1 as a subscript, means down, and mass number I will write as a superscript at the top. Okay. So, here similarly, for example, I want to write a carbon, and carbon atomic number is 6, mass number is 12, and carbon symbol is what? C. So, C6, 12, like this. Okay. If I want to represent the sodium, for example, okay, sodium. So, sodium can be represented, sodium symbol is Na, atomic number is 12, 11, mass number is 23. Okay, we can represent like this. So, the meaning is what? Overall, we represent like this. Okay, so this, for example, you think one element symbol, and we write Z at the down as a subscript. Z means what? Atomic number. And mass number we write as a superscript. So, this is the representation of element. Okay. Last and final topic. Okay. Now, so we can represent like this. Now, for example, see students, now very important point I am going to explain you. So, how can you find, okay, what information one if an element is there, okay, for example, I write one element, you can use, can you say in one element anything? Okay, I'll take one aluminium. So for example, here it is there, you think aluminium. If I see in the periodic table, you know the periodic table where all the 118 elements are arranged. Aluminium, if I see, I can find the aluminium in the periodic table like this. Okay, like this I can find in the box. Aluminium 13 and 17. What this information gives? So see students, it gives a lot of information. Okay, so what the information it gives here, I am writing here. First element. Okay, second atomic number. So simply I write Z. Okay, Z. Next mass number, that is A. Next protons, electrons, neutrons. This all information we can get from this element. Okay, from this symbol. Okay, so here Al. Al stands for aluminium. Aluminium. Okay, and here 13C in the subscript. So atomic number is 13. Superscript 27. So mass number is 27. I want number of protons. Number of protons is nothing but an atomic number. But atomic number is 13. So the number of protons are also 13. Number of electrons. See, protons is equal to electrons. Electrons is equal to protons. So electrons also will be 13. Now I want the neutrons. Neutrons, how can I find? See, neutrons is equal to A minus Z. A is what? Mass number. Mass number minus atomic number. Mass number 27, atomic number 14. So the number of neutrons are 14. Clear? Like this. For example, now you try now. For example, I am writing here Ca. No, I will take argon. Okay, argon with at here 18 and 40. Come on, students, fast. Try. Okay, so what is Ar represents? Come on, fast. Ar represents what? Argon. Very good. Oh, you are so fast. Okay, so Ar represents argon. Okay, now what is its atomic number? Atomic number is what? Here, denominator means a subscript, that is 18. Very good. What is its mass number? Good, that is 40. Now, how many protons are there? Protons is nothing but atomic number. Atomic number is 18. So, 18 protons are there. How many electrons are there? Protons and electrons are same. The meaning is what? 18 electrons are there. What is its number of neutrons? Number of neutrons is what? A minus Z. Mass number minus atomic number. Mass number 40. 40 minus 18 is 22 neutrons are there. Clear, students? Chalo, right. So, in this way, you can practice. Now, once if you have a material, you open the page number 142. 142, you can see here in the page number 142. Here the elements are given. Here atomic number, symbol is given. Atomic number is given. Mass number is given. You need to find the neutrons. So, you need to find all protons, electrons and neutrons. Very simple, no? So, protons is nothing but atomic number. For example, you take this book. Here, for example, I am taking one element like calcium, last element. Okay, calcium, it is given Ca, symbol is Ca, atomic number 20, mass number 40. Right? So, atomic number 20 means what? There are 20 protons are there. And how many electrons? Electrons also 20 only, because protons and electrons both are same. So, 20. And now neutrons is nothing but a mass number minus atomic number. Mass number is given here 40, 40 minus 20, that is equal to 20. So, number of neutrons are 20. Clear? Right? So, students, you practice this one. So, here 20 elements are there, that is hydrogen 2, calcium. So, this is all very important. So, this one, every point is there here. So, check this one. I think we are preparing the notes. If no problem. So, understood? No? So, with this we stop. So, we have completed the synopsis 1 and synopsis 2 from the atomic structure. And your work is to read the atomic structure 2, synopsis 1 and 2 perfectly and try to answer all the questions. Okay. Chalo, with this we stop our class. Bye. Take care.